Hello everyone, welcome back. We're going to go ahead and get started into chapter 0.2. So this is operations with fractions, and I'm probably going to split this up into two videos just because it's so long, and I have trouble uploading videos to YouTube anyway when they start getting kind of long. So I'm probably going to break this up into two videos, okay? So operations with fractions, so we're going to be doing adding, subtracting, multiplying, and dividing all in one section, which is a lot, okay? So the first thing we're going to do, the easiest thing to do with fractions is with multiplication. So that's where we're going to start first. So let's say we were given 2/3 times, that's a 5, 5/9, okay? 2/3 times 5/9, okay? To multiply fractions, it's pretty cut and dry. You are going to multiply straight across. You're going to multiply the two numerators together and the two denominators together. So you're going to do 2 times 5 is 10 over 3 times 9 is 27. Now we're dealing with fractions. You always want the least possible answer, right, when dealing with fractions. So if you can reduce, reduce. If not, that's your final answer. So there's no number, there's no common factor that you can pull out of 10 and 27. So that's your final answer there. All right, let's look at 3/5 times 2/7. Same thing, you're multiplying straight across. You're doing the two numerators. 3 times 2 gives me 6 over 5 times 7 gives me 35, okay? Is there a common factor I can divide out of 6 and 35? There isn't, so that's your final answer, okay? Now, there are some tricks when dealing with multiplication with reducing, okay? So let's go ahead and try one of those. Let's look at 2/4 times 1/2. 2/4 times 1/2. So the trick that you can do is you are going to look diagonally and see if you can reduce. Okay, so you're going to use that common factor method. See if you can, simplify by looking diagonally. So the first thing we're going to look at, let's look at the 4 and 1. Is there a common factor that I can divide out of 4 and 1? And there isn't, right? Nothing goes into 4 and 1 except 1, which doesn't change our answer. So we're going to look at the other diagonal. 2 and 2. Can I simplify 2 and 2? Yeah. Both are divisible by 2. So 2 divided by 2 is 1. 2 divided by 2 is 1. So now we've just changed the problem. And we are now doing 1 times 1 is 1 over 4 times 1 is 4. And that answer is reduced. Okay, you don't have to do anything else to it. It's already reduced. Okay, this is not the same thing as cross multiplication. That's with dealing with proportions, and we're not dealing with that yet. Okay, so this is not cross multiplication. Okay, you're just reducing diagonally. All right, let's do another one. Let's do 2/7 times 14 over 16. So 2/7 times 14 over 16. So it's the same thing. You're going to look diagonally. Let's look at the 2 and the 16. Is there a common factor we can divide out of 2 and 16? Yes, 2. So 2 divided by 2 becomes 1. 16 divided by 2 becomes an 8. Okay, let's look at the other diagonal, 7 and 14. Is there a number that we can divide into both? Yes, 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. So once again, we're still changing the problem. This also works with numerator to the denominator. Okay, so not only can you reduce diagonally, you can also reduce from top to bottom, numerator to denominator. So if you look here, 2 goes into 2 one time, 2 goes into 8 4 times, and now I have 1 times 1 left, which is 1, and 1 times 4, which is 4. Okay? Now, if you didn't spot that, that's okay. You would have had 2 over 8, and if you would have looked at 2 over 8, you would have known 2 goes into both, and you still would have gotten 1/4. You just would have taken an extra step to get there. Okay? Let's do one more of those, just to make sure that makes sense. Okay, let's look at 8 over 27 times 9 over 16, okay? So your very first step for these multiplication problems are going to be to look diagonally to see if you can reduce. If not, then you're going to start multiplying straight across. So let's look here at 8 and 16. Is there a number that goes into 8 and 16, right? A factor that I can divide out? Well, 8 goes into both, and if you weren't sure, right, you could have started with 2. You just would have had to do a couple more steps. So 8 divided by 8 is 1. 16 divided by 8 is 2. And then we're going to look at our other diagonal, 9 and 27. Is there a common factor for both? So if you notice, 9 goes into both, right? I can pull a factor of 9 out. You could have done 3. That's fine, but like I said, you would have had to reduce again. So 9 divided by 9 is 1. 27 divided by 9 is 3. Now I can multiply across with our 1 times 1 that's left to get 1, and our 3 times 2 to get 6. Okay? Sometimes you're not going to be given just fractions to multiply. Sometimes you're going to be given a fraction, like 2/5, times a whole number, like 7. Okay? So 2/5 times 7. You can only multiply fractions by fractions, okay? And right now, whole number 7 doesn't look like a fraction. So in order to make 7 a whole number, a fraction, you are going to put it over 1. So you need the denominator to be 1. Now, if you write that as 1 over 7, well, you just changed it and made it a fraction 1/7. So it needs to be the whole number over 1, 7 over 1, okay? Now we can go ahead and multiply. Look diagonally. Does anything reduce? Nope, nothing reduces. So you're going to go ahead and multiply straight across. 2 times 7 is 14 over 5 times 1 is 5. Now I have this fraction, 14 over 5. What kind of fraction is that? The numerator is greater than the denominator, so that's an improper fraction. Sometimes you're allowed to leave your answers as improper fractions. Other times, you are to turn these back into what's called a mixed number, and we're going to get into that here really soon. Okay, but for now, we can go ahead and leave this as our answer. Let's look at another one. Let's look at 8 times 1/4. Once again, you can only multiply fractions by other fractions. So we're going to turn the whole number 8 into a fraction by putting it over 1, okay? Now we're going to look diagonally and see if we can reduce. I'm looking at the 8 and 4. 4 does go into both, right? It's a common factor of both. So 8 divided by 4 gives me 2. 4 divided by 4 gives me 1. So I have 2 times 1 is 2. 1 times 1 is 1. And I can reduce that, right? Because this is essentially a division problem. Remember, fraction problems are division problems. 2 divided by 1 is a whole number 2. Okay, so that should be reduced, okay, to a whole number 2. All right, so that's multiplication. Now we're going to get into division. There's a little bit to remember with division, okay? But what we're going to do is we're going to turn it into multiplication problems that we know how to do really well, okay? So what you're going to do is you are going to be multiplying by the reciprocal. So let's go ahead and do an example. Let's do 5/9 divided by, and we're going to do 10/3, okay? So essentially what you want to do is keep first fraction the same. Then you want to change division to multiplication. Then you want to flip your second fraction. This is also known as taking the reciprocal. Okay, so you're going to keep the first fraction the same, change division to multiplication, and then you're going to flip the second fraction, which means taking the reciprocal. Okay, so let's go ahead and apply this. Keep first fraction the same, so we're bringing down the 5/9. Division needs to be changed to multiplication. We're going to flip the second fraction, take that reciprocal, so instead of 10/3, this now becomes 3/10. Okay? Now we've changed this to a multiplication problem, we can apply our multiplication rules. So our first step is always to look diagonally and see if we can reduce. We can, right? Let's look at the 5 and 10. 5 goes into both, so 5 divided by 5 is 1. 10 divided by 5 is 2. Let's look at our other diagonal, 3 and 9. They reduce. 3 goes into 3 once. 9 divided by 3 is 3. Now we can go ahead and multiply straight across. So now I have 1 times 1 is 1. Over 3 times 2 is 6. It's reduced, and that's our final answer. Okay? So I hope you remember that. You remember the division. So let's go ahead and do another one. Let's do 27 over 36 divided by 1/9. Okay, so 27 over 36 divided by 1/9. So we are going to keep the first fraction the same. Division becomes multiplication, and we are going to be flipping the second fraction. So instead of 1/9, this now becomes 9 over 1. Now we're set up like multiplication. Let's look diagonally and see if anything cancels. Well, 27 and 1, nothing reduces, nothing cancels. So let's go ahead and look at 9 and 36. 9 goes into 9 one time and goes into 36 4 times, okay? From here, we can go ahead and multiply straight across. Well, 27 times 1 is 27. Over 4 times 1 is 4. And now we're left with an improper fraction of 27 over 4, okay? Now, you're not always going to be given two fractions. Sometimes you're going to be given whole numbers. So let's look at 3/4 divided by whole number 3. So just like multiplication, you cannot divide fractions with whole numbers. You can only divide fractions by fractions. Okay, it's the same thing as multiplication. Multiplication, you have to multiply fractions by fractions. Division, you have to divide a fraction by fraction. So once again, we're going to turn a whole number, 3, into a fraction by putting it over 1, just like we did with multiplication. After we have turned that into a fraction, now we can go ahead and apply our rules, okay? And the reason why we go ahead and do this first is so that we flip, right, our second fraction properly, okay? So first fraction stays the same, division becomes multiplication, and we're flipping the second fraction, and it now becomes 1/3, okay? Look diagonally, see if anything cancels. Well, 1 and 4, nothing goes into 1 and 4, but the 3s, 3 goes into both. So 3 divided by 3 is 1, 3 divided by 3 is 1. And now we're going to go ahead and multiply straight across. So 1 times 1 is 1, over 4 times 1 is 4. Can't reduce any further, so that is our final answer, okay? Let's do another. Let's look at 3 divided by 3/4. So let's flip that around, okay? Same thing. You can only divide fractions by other fractions. So we're going to turn our whole number 3 into a fraction by putting it over 1. Now we can apply our division rules. Let's keep the first fraction the same. That stays 3 over 1. Division becomes multiplication. Now we're flipping our second fraction, so this now becomes 4/3. Now we're going to look diagonally, see if we can reduce. Well, 1 and 4 does not reduce, right? Nothing goes into those except 1. Let's look at our other diagonal, the 3s. 3 goes into 3 one time. 3 goes into 3 one time. Now we can multiply straight across. 1 times 4 is 4, over 1 times 1 is 1. Well, this reduces, right? Because essentially they're division problems. 4 divided by 1 is a whole number 4, okay? So like I said, I hope you remember this at some point, that you've done this in high school at some time, okay? All right, let's go ahead into adding and subtracting. Let's go ahead and look at adding and subtracting. When you add and subtract fractions, you must have a common denominator. So when you add or subtract fractions, you must have a common denominator. So this is very important. Multiplication and division, we could care less. Doesn't matter what the fractions are. Doesn't matter what the whole numbers are. we make it work. We don't need to worry about common denominators, okay? But adding and subtracting, you have to have a common denominator, okay? So don't get that confused. So let's look at some examples. Let's look at 3/10 plus 1/10, okay? So the first thing we're going to look at is, are the denominators the same? So those bottom numbers, are they the same? Well, this is 10 and this is 10. Those are the denominators. It's the same. So when they're the same, you add or subtract the numerators, okay? So here I have 3 plus 1 gives me 4. You keep the denominator when you add and subtract fractions. You keep that denominator. You don't add them together. You don't subtract them. You only add or subtract the numerators, okay, the top numbers. So if I had 8/7 minus 5/7, first thing we're going to check, do we have the same denominator? Yes, they're both 7s. So that means we can go ahead and subtract the numerators. So 8 minus 5 gives us 3. It stays over the denominator of 7. You do not add or subtract that denominator. It stays the same. So this answer would be 3/7. Always reduce if possible, right? We didn't reduce up here. So let's go ahead and reduce 4/10. What goes into 4 and 10? 2. So you divide both by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5, right? So we always reduce if possible. Okay? Now, more times than not, your denominators are not going to be the same, okay? So this is where that building equivalent fractions that we did in the last section becomes really important. Same thing with least common multiples, except now we're going to call them least common denominators, LCDs. So you may remember that at some point in another math class. So we now need to talk about least common denominator, that's an E, or your LCDs, okay? It's the exact same thing as finding a least common denominator, or least common multiple, I'm sorry, except you're going to look at the denominators of a fraction, okay? So, let's find the LCD, least common denominator, for 5, 6, and 1/4. So you're going to find the LCD, least common denominator, for 5, 6, and 1/4. Well, it says least common denominator, so look at your denominators. 6 and 4, okay? You're doing the exact same thing as least common multiple. We're going to look at 6 and we're going to look at 4, okay? So now we're going to start that process just like we did for least common multiples. 6 times 1 is 6. 6 times 2 is 12. 18. 24, right? So on and so forth. Same thing with 4. 4 times 1 is 4. 4 times 2 is 8. 12, 16, 20, 24, so on and so forth. So a common mistake that I see here is that you look at this really quick and you go, oh, well, they both have 24 in common. Yeah, that's great, but it's not the smallest number that they have in common, the smallest least common denominator they have, right? They have 12 in common as well, and it's smaller, so you're always going to want to use the smallest numbers possible, okay? So you're going to want to use 12. So your LCD is 12, okay? Your LCD is 12, so that's this process, and we just did a bunch of this in the first section, right? Least common multiple, it's the same process, least common denominator. All right, so after we find the least common denominator, then we can build equivalent fractions. So they're not always going to tell you what the denominator needs to be. So you know how when we built equivalent fractions before, it said we had, you know, fraction of 5, 6, and we want the denominator to be 20. They're not always going to tell you that. So we're going to have to discover that ourselves. So let's go ahead and do a problem. Let's look at 5, 6 plus 1/4. Okay, now we just found the LCD for these two fractions, right? We just did 5, 6, and 1/4, and we discovered the least common denominator was 12. Okay, so we found that second piece of information, right, that they told us before in the first section. So now that we did that, we got to build equivalent fractions so that we can add. Because right now we can't add. Denominators are different. They're 6 and 4. We need them to be 12. Okay, so we're going to start that circle process. Our circle method that we did before. Okay, so let's do this 5, 6 first with the denominator of 12. So in the left direction, we're going to do 12 divided by 6 is 2. 2 times 5 is 10. Okay, now we're going to do the same thing with 1/4. So 1/4 with the denominator of 12, we're going to do the circle method. So in the left direction, we're going to divide. So 12 divided by 4 is 3. 3 times 1 is 3. So we now have our two fractions that we can add together. So I have 10 over 12 plus 3 over 12, and I can add them because the denominators are the same. They're both 12. Add the numerators. 10 plus 3 is 13, and it stays over 12, and that is an improper fraction, okay? All right, let's go ahead and let's look at another one. Let's look at another one. Let's do 5/12 plus 7 over 18. So 5/12 plus 7 over 18. So the first thing we're going to look at, do they have the same denominator? Nope, they're different, 12 and 18. So our first step is going to be to find the LCD, okay? So we're going to look at 12 and we're going to look at 18, just like we did before with finding least common multiple. So start with 12. 12 times 1 is 12. Times 2, we have 24. What else do we have? 36, and we can stop there, okay? And let's go and look at 18. 18 times 1 is 18, times 2 is 36, and we can stop, okay? So we see that they both have least common multiple of 36, so our LCD is now going to become 36. So now we're ready to do the work of building an equivalent fraction so that we can add. So let's start with 5/12, and we want to change the denominator to 36. So let's do our circle method, right? We're going in the left direction. We're dividing first, so 36 divided by 12 times 5, we end up with 15, right? 36 divided by 12 is 3. 3 times 5 gives us 15. And we're going to do the same thing with 7 over 18 with a denominator of 36. Building equivalent fractions, we're using our circle method. In the left direction, we're going to divide. So we have 36 divided by 18 is 2. 2 times 7 gives us 14. So now we have our two fractions that we can go ahead and add together. So we have 15 over 36 plus 14 over 36. They have the same denominator, so we can add the numerator together. So 15 plus 14 gives us 29, and it stays over 36. Look at your fraction, double check to see if you can reduce. We cannot, okay, we cannot reduce. So that's our final answer. Let's do 2 of these where we are subtracting, and then we're going to stop and take a break and come back for the rest of this section, okay? So hang in there. I know it's really different than being in the classroom, and trust me, it's very weird teaching this way, not having you in the class to get feedback. So like I said, if you have questions, you've got to let me know, okay? All right, let's subtract. So let's do 8 over 25 minus 3 over 20, okay? So we're subtracting. It's the same thing with adding. Do we have a least common denominator? Not at the moment, right? It's 25 and 20. It's different. So we're going to find our LCD, okay? And hopefully by looking at 25 and 20, you know that the LCD is 100. If not, write them out, right? You would do 25, 50, 75, and 100, and for 20 be 20, 40, 60, 80, and 100, and you would find out that it would be 100, okay? So if you still need to do that work on the side, by all means, do that work, okay? All right, let's build those equivalent fractions. So I have 8 over 25 equals, we don't know, over 100. And now we're going to do our circle method, moving in the left direction. So 100 divided by 25 is 4. 4 times 8 gives us 32. Same thing we're going to do with the 3 over 20. We're setting up our problem. And we're moving with our building equivalent fractions in the left direction. So 100 divided by 20 is 5. 5 times 3 gives us 15. Now we're ready to go ahead and subtract. So now I have 32 over 100 minus 15 over 100. They have the same denominator, so we can go ahead and subtract. So 32 minus 15 leaves us with 17. Stays over 100. Look to see if you can simplify. We can't, right? And 17 is a prime number, so nothing goes into it but 1 and 17. So we're done with this. Okay, so I hope this is starting to make sense. Okay, so like I said, adding and subtracting, you're doing the same thing. Okay. All right, let's go ahead and take a quick break, and then I'll come up with a part 2 video for this section that's going to be dealing with mixed numbers, okay, with mixed numbers. So it's another hunk of this section, all right? You need me, let me know. Thanks.